Question number 13. The diagram shows an experimental to determine the force exerted on a ball by a horizontal airflow. Okay, so air has been flown like this over here. So as a result of it, the ball is moving like this. The ball is suspended by a light string and weighs 0.15 Newton. So this weight is 0.15 Newton. The deflection of the strings from the ball is 30. Ball is in equilibrium. Okay, what is the force on the ball from the airflow? The moment you say equilibrium, you can apply FBD. So what is the FBD here? So this is the tension over here. If this is 30, then this should also be 30 degrees, right? If this is 30, the component of tension along this direction should be T cos 30 and along this direction should be T sin 30. Now let us write down the equations. What is the equation here? I'll write T cos 30 is equal to 0.15. T sin 30 is equal to airflow. What is the force? Force we do not know. We need to find F here. So we need to find F. Divide one by the other. I get T sin 30. T sin 30 divided by T cos 30 is equal to F divided by 0.15. So that the T and T gets cancels. I get tan 30 here. So tan 30 is equal to F divided by 0.15, or I can now write F is equal to 0.15 times tan 30. Okay, now let me use the calculator to get the actual value of this, which will now be equal to, what is tan 30? So let us take this value, tan 30, I'll take this and then find out. Tan of this 30 value 0.577 multiplied by 0.15 will give me 0.086. 0.0866 I got, which is nearly 0.087. 0.087 is answer B. Okay.